Hi, I'm Pat North, and I'm going to talk to you today about initialization and calibration. And this is specifically for imaging systems. And the whole idea with initialization and calibration is you are going to go from some point in design to operation. And you want to be in this nominal operating state. And from this process, there's going to be some point in time where you're going to calibrate everything to get into that perfect working order, and that's going to be your initialization. And you're also going to have some routine calibration that you're going to do, some ops tempo where you're going to update your calibration variables every so often to stay in that nominal working order. And the whole idea with initialization and calibration is you've got your design, build, integrate process, but you're also going to have some process running in parallel. And this parallel process is just for the folks that are going to be involved in keeping your system running nominally. So that's your ops team, that's your calibration team. And it's really three-part. You've got your team, your tools, and your training. And throughout this process, you're going to have all of these regular exercises to get ready for that big initialization event. Because you've got all of these different subsystems. You've got your payload, you've got your comms, you've got your platform, you've got your command and control, you've got your data processing. You've got all of these different subsystems, and the folks that are going to be responsible for making sure all of these different pieces are working together well are going to be your ops team. And for that first initialization event, all of these folks are going to need to be perfectly coordinated. It's just like an orchestra. All of these instruments are going to be playing together, and it needs to go pretty seamlessly to transition as quickly as possible into this operational state. And in order to ensure that, you're going to have a bunch of different rehearsals, test exercises to get you into that state so that everyone's ready once you hit that event to start your initialization and get into that nominal operating state as soon as possible. And the things that are going to help you be successful in this are incremental testing, training, SOPs, and you have anomaly and discrepancy, and you have test data. And these 5 things are going to help you be successful in that initialization event. And the incremental testing, you basically don't want to jump too far too fast. As things are being integrating, once you plug things in for the very first time, you want to make sure the right data is coming in and out of that component. You also want to make sure that throughout this, even before you start doing integration testing, you want to make sure that you're doing your training exercises so that everyone knows where they're sitting. Everyone's got the right accounts, everyone's got the right tools in place so that early on in the process you can see if there's any missing parts. In addition, you want those SOPs developed and you want to iterate on them so that as you're getting closer and closer to the big initialization events, you've got all of those on autopilot. You also want to make sure that every new component or new system is going to have surprises, and you want to make sure that you have a process in place to handle those anomalies and those discrepancies. You've got that short list of people to get involved and to approve new fixes and changes as you go. Finally, you also want to make sure that you have test data being exercised throughout this system. Before you've got actual operational data, you want to start testing out that, once you connect all these pipes and you push representative test data through, you want to make sure it's watertight before you send that system thousands of miles into outer space or start flying it on a critical mission. So all of these things are going to help you make your initialization event successful. In addition, you also want to have your calibration plan. And that's going to change over time. And your calibration plan, it's always going to be this balancing act where you want to have some lion's share of the time being dedicated for operations, but you're going to have some sliver of time for the calibrations. And the calibrations are important because no matter what, as you operate, your performance is going to degrade. And every so often, you're going to do that calibration to get you back up to where you want to be. And it's going to degrade slowly. And you're going to have some threshold and say, Here's where I can tolerate performance. And once I degrade below this, I want to know what my ops tempo is for having to redo these calibrations. In addition to that, towards the end of the lifetime, you're going to start putting more and more of this time into things like, we already know our calibration cycle. This is where we want to start doing things like experiments. So you're going to start doing things out of the ordinary and fill in some of that information that you might have not wanted to do during the early life cycle of your system. And that's all I had to say about that. Thanks for listening.